Okay, we're working on week 2, chapter 3.1, 3.3. So what do we have? The probability that an event will happen is 37 over 41. We need to find the probability that the event will not happen. Okay, the probability for the event that will happen is 37 over 41. So the probability for the event will not happen. So let's understand what means 37 over 41. That means total we have 41 and 37 happened, event. So no event, the probability that event will not happen, it's going to be 41 minus not event. It's going to be 41 minus 37, yes? So it's going to be equal 4. Now, not event that will not happen is probability 4 or out of total 41. And that's going to be our answer. So let's see. Here is 4. Here is 41. Okay. Enter. Excellent. Moving to next question. So now the probability that event will happen is 0.43, decimal notation, okay? Find the probability that event will not happen. In the decimal format, 0.43, let me clean this. 0.43. Event will happen. Maximum probability, what is probability? It's an event, it's a percentage, right? 100% or 1 total. So if 0.43 will happen, that means the fact that the probability will not happen, we do 1 minus 0.43. So it's going to be 0.57. 1 meaning portion-wise 100%. Because we don't put 43%, we put 0.43, therefore 100%, we put 1. So 1 minus 0.43, we get 0.57. So 57% chance that the event will not happen. Let's write down 0.57. Very good. Moving to next question. Probability that event will not happen, 0.81. Now we need to find the probability that event will happen. That's same easy problem. Event not happen, this either this way or this way. They gave you this way, I'm using this way, but both notations are correct. If it's will not happen 0.81, then probability that will happen, it's going to be 1 minus 0.81, right? It's going to be 0.19. Pretty straightforward. Fantastic. Moving to next question. All right. The probability that person in the United States, okay, has type blood plus is 13%. Okay, 3 unrelated people in the United States are selected at random. Complete parts A through D. All right, let's get going. So, question A, find the probability that all 3 have type B plus blood. So when all 3, we can interpret that and first and second and third, and every time when we can replace with the word and. All 3 have, that means and first and second and third. We and convert into mathematical multiplication. So if we have 13%, probability for B plus is 13% or 0.13, then what we are going to do, we are going to take and multiply by each other. Okay, so it's going to be 0.13, 0.13, and times 0.13. Okay, so we do 0.13 times 0.13 times 0.13. We have three, right? Independent, yes, and 0.13 for each independent event. So from here, what we are going to do, take and multiply. So let me see, 0.13 times 0.13. I don't want to turn my calculator to get scientific, so to raise to power 3. Just simply multiply 3 times. And I'm getting 0.002197. Let's see what's the rounding deal. So let me read. Round to 6 decimal places. Well, then that's what we have. 6 decimal places. What happened? Oh. If I can. Okay, let me go back and then come again. There we go. So 0 point 0.002197. 1, 2, 3, 4, 5, 6. Okay, fantastic. Next question. Find the probability that none of these have type B plus blood. Okay, for none of them, since 13% have the type B plus, then no B plus, it's going to be 1 minus 0.13, right? 0.87. So which means in this case, 0.87 doesn't have, second one also 0.87, which means doesn't have B plus, and third one also 0.87. So let's multiply 0.87 times 0.87 times 0.87, and we are getting 0.65853. Zero point 65853. What is wrong in this case? Let me double check again. 1 minus 13%, it's going to make 87%. So let me clean. 0.87 times 0.87 times 0.87, and I'm getting 0.65853. Ah, 65853. That's correct. Three decimals, duh. No, that's why it doesn't make sense. One they want 6, the other one they want 3. So it's gonna be, if we round till 3 decimals, it's gonna be 659. Okay. Next question: find the probability that at least one of the 3 has type blood pressure. So at least one, probability for at least one is B plus. So which means if I take 1 total 100% minus the fact that none of them has, which is going to be 0.656. That is going to be at least 1. So minus 6556, 1 minus 0.656, we are getting 0.344. Zero point 344. Oops. Is there any rounding again? Till 3 decimals. Yeah, we rounded. Oh, 659. Okay, hold on. 1 minus 0.659. Didn't pay attention. 341. Okay. Okay. Next, which event of this event is considered unusual? So unusual is in part A, because the probability here is less than 5%, is 0.2%, which is least likely. So part A is this one, because it's it's not even 1%, that's 0.2%, that's unusual. Okay, and this is going to be our answer. Let me check it. Excellent. So moving to question number, do we have more? No, we are moving to question number 5. So how are we going to solve this problem? Let's see what we're going to do with this. All right. According to the study, 90% of K-12 school or district in a country use digital content such as ebook, audiobook, and digital textbook. Of these 90%, 6 out of 10 use digital content as a part of their curriculum. Find the probability that randomly selected school or district uses content and uses it as a part of their curriculum. Okay, we have 90% and we have 6 out of 10. So let's see. So probability for, let's say, event A, the one that is 90%, we put 0.9. So probability for the other event, we put, it was 6 out of 10, right? One more time, 6 out of 10, correct. It's going to be 6 out of 10. Or I can put in the decimal notation. Okay, 0.6. And then because it's asking for and, let's see one more time. Find the probability that randomly selected school or district uses digital content and, so the one that using digital content is 0.9. No, that is, 0.9, and uses as a part of their curriculum is 0.6. So because these two events are connected via and, look here, find the probability of randomly selected school or district uses digital content and uses it as a part of their curriculum. So, and every time we convert into mathematical multiplication. So we are going to take 0.9 and multiply by 0.6. 0.54. Okay, let's go place the answer. Fantastic. Moving to next question. What is our next question? The probability that a randomly selected student excuse me, is a female or a physics major. Okay, in this case, since we have or, female or, we always convert into addition. Excuse me. So these two events, we're gonna add them, not multiply. If it would say find the probability that randomly selected student is female and physical major, then probability of a female we would multiply by probability of physics major. But because it says or, we're going to add. So let's find the probability for female. It's gonna be, let's see, physics has 50 students. Of these, 17 students are physics majors and 14 are female. So 14 are female. Probability of female, 14 over 50. And probability of physics, how much was it? 17. Okay, 17 over 50. So because it says or, then we need to add 14 over 50 plus 17 over 50. We are going to get 31 over 50. Now, let's divide 31 divided by 50, and we are going to get 0.62. Okay? 0.62. Okay? What is this here incorrect? There is nothing to be incorrect. Okay, let's do over. Maybe it's see, I didn't finish reading. That's my fault. Of the physics major, 4 are female. Okay, that's the catch. Of physics major, 4 are female. So out of the 17, 4 are females. So this 4, we count it and as in the female, and we count it as physics. So 4 people are getting duplicate. Therefore, what we need to do, we need to subtract this 4 over 50, eliminate duplicate. You understand? So it's this out of 17 physics, we have 13 male, 4 female, but in probability of female is 14. So these 4 being counted and here and here. So it's when to avoid duplication, we are subtracting. And it's equal 14 plus 17, it's gonna be 31. 31 minus 4, it's going to be 27 over 50. Now, this time it's going to be correct. 27 divided by 50, and we are getting 0.54. Didn't we get the same thing by some reason? 54. Yeah, I was wondering, how can we get the same answer? Okay. Fantastic. Next one. So what do we have in this case? Of the cartons produced by a company, 8% have puncture, 5% have smashed corner, and 1.2% have both puncture and smashed corner. Find the probability randomly selected carton has puncture or smashed corner. All right. So that's probably approximately same thing. So we have 8%, 5%, and 1.2% belong to both of them, right? And to puncture and to 5%. Therefore, this is what we will do. We need to add, because it says or, probability that randomly selected curtain has puncture or smashed corner. So we take 8%, adding 5%, it's going to be 13%, and subtract the duplicate. 13% minus 1.2%, and we are going to get 11.8%. Okay, next question. Question number 8. So what do we have here? You roll the 6-sided die. Find the probability that each of the following scenarios, rolling a 4 or a number greater than 3. Okay? Rolling a 4 or number greater than 3, it's going to be 4, 5, 6, right? So let's do the probability. How many 4s we have? We have only one element that has 4, right? So and it's going to be 1 out of total. We have 6, right? On the 6-sided die, okay? Here we have how many? 3. 3 out of 6. Because we have or, we are adding 1 over 6 plus 3 over 6. And we need to subtract the duplicate, which is 4 here. This 4 here and here. It's only one element, so we subtract 1 over 6. Okay? So this one plus 1 over 6 minus 1 over 6 is gone, and we are getting 3 over 6 or 1/2, which is going to be 0.5. Let's put that number. Okay. Good job. Moving to next question. What do we have in this case? Probability of 1 or 2 or 3 or 4 or 5. Okay? Or 4 or 6. So we have two choices. Here is missing only 5, right? So we either can add, probability of 1 is 1 over 6, probability of 2 is also 1 over 6. Why? Because the value doesn't matter, 1, 2, 3, 4. It matters how many of those there. There is only 1 times 1, so 1 over 6. There is only 1, 2 of 2, and it's going to be 1 over 6 for 3, also going to be 1 over 6, because we don't count the value, but count the quantity. So all is missing is 5. So either we can add 1 over 6 5 times, right? 1 over 6, 1 over 6, 1 over 6, 1 over 6, or we are missing there 5. Probability of 5 is 1 over 6, right? And if I take probability of 5, is 1 over 6. So the probability for the rest, it's going to be 1 minus 1 over 6. 1 I represent as a 6 over 6 minus 1 over 6. We are getting 5 over 6. If I divide, I get 0.833. Okay? .833. Okay. Good work. We have anything else? 4 or 1 or 3 or 5. Well, it's the same thing. Here you can either add all of them or subtract. So since there are 4 of them, this time I'm adding 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6. 4 of them, right? And we are getting 4, since denominator is the same, we are adding numerator 4 over 6 or 2/3, and that will give me 0.667. Okay. 0.667. All right, we are done. Moving to next question. What do we have here? We are given table, nursing majors, non-majors, not nursing majors, and male, female total. Okay, let's get going. So find the probability that the student is male or nursing major. Since we have or, then we're gonna add probability of male. It's gonna be how many males we have total? 1,110 out of total 36. Let me write down on piece of paper, and then I'll move it to 1110 over 34. That's male. And then nursing major, for nursing major total is 797, because nursing major goes by column, so 797 over same 3534. But here is the thing, male and nursing major. So you see 97, it's reduplicating. It's because it belongs to male and it's nursing major. So 97 was counted twice. Therefore, we need to subtract 97 over total 34. Let me now write down what I just said. So, probability of male is 1110 over 3534. Probability of nursing major, 797 over 3534. Now remember one thing, one is going horizontally, the other one goes vertically, so that means there is an intersection, and that intersection, that is 97, it's going to be duplicate. So probability of male and nurse, this is and 1%, it's going to be 97 over 3534. So from here, 1110 over 3534 plus 797 over 3534 and minus 97 over 3534. Let's do the math. 1110 plus 797 minus 97, and I'm getting 1810 over 3534. Since we need in the decimal notation, we divide 1810, I divide by 3534, and I am getting 0.512, rounding till 3 decimals. It was asking to 3 decimals. 0.512, let me put in there. 0.512. Oops. Well done. Next one. Find the probability student is female or not nursing major. So for female, total female is 24 out of 35. 35. That's a female. Not nursing major is 27 because total by column. 27 out of 34. And duplicate, we need to subtract duplicate for female and not nursing major. It's going to be 1724. That is and non-nursing major and female. Minus 1724 out of 34. Okay, let me write down here. So we have 24 out of 34 plus 27 37 out of 35, 34, and minus 17, 24 out of 35, 34. Okay, and what we are getting, let's see, 24, 24 plus 27, 37, oops, messed up, 24, 24 plus 27, 37 minus 17, 24, and I'm getting 34, 37. Now when I divide 35, 34, 35, 34, and I'm going to get 0.97. 0.97, okay, 3 digits, 973, okay? Zero 0.973. Good job. Next one. So, not being a female or being a nursing major. Not being female, we have only one option, male. So it's again 1110 over 35, 34 overall total. It's a not being female. And being a nursing major is 797 over 35, 34. But here is what is interesting. So female and nursing major, it's a common is 700, duplicating 700, right? Yeah, no, I'm sorry. Not being female. Common is gonna be male. So, well, we solved this one already. Being male and being nursing major, because when it says not being female, that means being male. And it says, or being nursing major. So it's the same as the first question. So 0.512. They just twisted the words there around. Well done. Okay. What else we have left? So what is, are the event being male or being a nursing major mutually exclusive? Let me see. Male, a male, and no, and being nursing, no, because we have nurse and male. We have 97 students who are and male and nursing major. So it's gonna be no, because there are 97 males majoring in nursing. Why is it wrong? Ah, I put yes, okay, no, the opposite, this one. I said no because they are not mutually exclusive. Sorry, just pushed the wrong button. Next question. Question number 10. Well, this is gonna be same, very similar. Find probability that the person opposed the change or is female. Okay, oppose the change, total we have 619 over 1044. Or a female, how many females? 542 plus 542 over 1044. And how much is their intersection? That is oppose and female. It's going to be 294. So minus 294 over 1044. Let me write down. It's going to be 619 over 1044 plus 542 over 1044 and minus 294 over 1044. Let's go. 619 plus 542 minus 294. And we are getting 867 over 1044. Let me divide by 1044. and we are getting 0.83. 830. Okay, 0.83, 0.83. Fantastic. Next one. Find the probability that person supports the change or email. That's supporting the change. It's 393 total. 393 over 1044. Or mail, how many total mail? 502 over 1044. And how many support duplicating that it's, and supporting and mail? 163 minus 163, 1044. Okay, let me write down this. 393 over 1044 plus 502 over 1044 and minus 163 over 1044. And we are getting 393 plus 502 minus 163. And we are getting 732 over 1044. Dividing 1044. And we are getting 0.701. Okay, 0.701. Good job. Next one. We need to find the probability that person is not unsure or is a female. Okay, so when we say is not unsure or is a female, it is going to be a complementary event for is unsure and is a email and is a male. Okay, therefore we need to find the complement of is unsure and male. One more time. When we say it's not unsure or is a female, that is the complement to that is unsure and is a male. So therefore, if I find probability of unsure and is a male and take the complement, I will get probability of unsure or is a female. So the probability for not unsure is or is a female. So probability of unsure or is a male is 14. 14 out of 1044. 14 out of 1044. And if we take the complement, minus will be probability of not unsure or is a female. So here we get 1044 minus 14 over 1044. This is going to be 10 and 30 over 1044. Okay, so 30 divided by 1044, we are getting 0.987. 987. Let me put the answer. 0.987. Okay, bingo. And the last question, are the event being male and support mutually exclusive? No, because we have a table and every column is crossing every row, so nothing here is mutual. Because so we are saying here no, because 160 males are the males that support the change.